Hello guys, welcome back to my Chem Corner. So in today's video we are going to do another question from chemical bonding and molecular or biomolecular structure. So the question is on question number 4.6. Write favorable factors for the formation of the ionic bond. Now we've seen in a few previous videos where I've spoken about how an ionic bond is formed and how a covalent bond is formed and what sort of elements form these ionic and covalent bond. So now in this question we're going to deal with favorable factors required for the formation of ionic bond. So this is basically question number 4.6 in NCERT. Now the ionic bond, as I told you, it involves transfer of electrons from a metal to a non-metal. The type of force that exists in an ionic bond is an electrostatic force of attraction. This is a very basic thing. Now, what are the favorable factors? Something that is responsible for the ionic bond. So, first thing is you should have low ionization energy, okay, of the metal. So say for example, I have a compound NaCl. Now this is an ionic compound because sodium is a metal and chlorine is a non-metal. Sodium will give its electrons to chlorine, therefore it forms an ionic bond. Okay, so it says low ionization energy of the metal. Now low ionization energy meaning it should be easier for us to pull an electron from the valence orbital of that metal. So in case of sodium, if I'm looking, sodium, the electronic configuration is this: 1s2, 2s2, 2p6 and 3s1. Why is it easier for me to pull an electron from its valence orbital? This is your valence orbital for sodium. So there's only one electron here. If it loses that one electron, then the remaining is going to be of the nearest noble gas configuration, which is neon. So here it loses that electron. Now it's easier for us to lose this one, to extract this particular electron easily. So therefore, when it is easier for us to remove an electron from a valence orbital, then you will have a low ionization energy because you really don't have to apply that much of energy to pull out that electron. So therefore low ionization energy of the metal is required, which means it makes it easier to lose electrons. Okay. Now second thing is high electron affinity of whom? Of the non-metal. So if you have low ionization energy of the metal, then it has to be the opposite for the non-metal, high electron affinity. This non-metal standing here must have that higher energy to pull the electron from sodium. All right, so it can easily form anion. All right, so here the ones that generally have a high electron affinity are your halogens, which is basically chlorine, fluorine, bromine, and all of that. Okay, so low ionization energy of the metal, high electron affinity of the non-metal. Now, third one should be a large difference in electronegativity. All right, now when you say large difference in electronegativity, that means to say that between sodium and chlorine, chlorine has a tendency to pull electron more from sodium, and sodium has that tendency to give away. So that means that itself shows a huge difference in their electronegativity. Okay, for example, the electronegativity of sodium on the Pauling scale is around 0.93, and that of chlorine is 3.16. So if you see, the difference itself is so high Therefore, this when two elements have difference in the electronegativity, definitely they will form a high boiling. They will form an ionic bond. Now, if I take a difference of both of this, it will come somewhere around 2.23. So that is a huge difference between both the elements in their electronegativity. So a large difference between the electronegativity of two elements will form ionic bond. Next one is something you've studied in Fajans rule. Small size of cation and large size of anion. This is something you learn in Fajans rule as well. If you take sodium, sodium loses one entire shell when it is forming a sodium ion. So the size will reduce even more smaller. Whereas chlorine, it will accept that electron. In some of the elements, it forms a new shell when it is accepting an electron. So in that case, the size of the cation will be larger, anion will be larger when compared to cation. So small size of the cation and large size of the anion will favor ionic bond. And the last one is high lattice energy. Now this high lattice energy will result in a more stable compound. Alright, now what do you mean by high lattice energy? That means when the compound is forming, it will release enormous amount of energy. The crystal lattice will release a huge amount of energy. Therefore, when the higher lattice energy is there, it will favor ionic bond. Alright, so low ionization energy of the metal, that means high electron affinity of the non-metal, they go opposite. Then large difference in the electronegativity between the metal and the non-metal. Small size of the cation and large size of the anion. This goes as per your Fajans rule. And in the end, last one is high lattice energy. By high lattice energy, it says when sodium chloride is forming as an ionic compound, it will release a huge amount of energy. Once it releases huge amount of energy, then we say that the molecule is a stable one and it results in the formation of an